is that we have a ray and this point is O, this is A and this is B, and if we can mark the lines here, and similar we can draw as many triangles as possible. So all this triangle has a common ray which is 30°, correct? All this makes up 90°. And now do you think all the triangles are similar triangles? All the triangles which will, whatever the triangle that we draw with a perpendicular line, will all these triangles be a similar triangle?
Similar as in like congruent?
A2, A3, B1, B2, B3, and it goes on, it goes on. The similar as in, so this triangle especially, this triangle OA1, B1, is it similar to triangle OA2, B2? Do you think?
Just a second. Yes, yeah.
Yes. So this will be similar to all other triangles. The triangles in the sense, instead of O, A2 and B2, if I take triangle O, A3 and B3, still this will be a similar triangle, correct?
Correct.
And one interesting thing that we observe, even in our last observation, is that, so, okay, so in our last observation is that, so if you take this side A1, B1 for two triangles with 30°, A2, B2, then the A1 by B1 is same. We realize this, correct? The height to the base.
Yes.
Right. So, even this is true for this case. Why? Because all are similar triangles, and if you measure A1, B1 divided by OB1, this is a constant, and this constant, it's true for even a small triangle or a big triangle. So it's actually true for A3 to B3 divided by OB3. So no matter how small triangle it is or big triangle it is, the ratio, if you take a ratio to the height to the base in a right angle triangle, it is constant. This is the basic idea. And this constant is what we refer as tangent ratio. Okay. So let's say, for example, so this tangent ratio is true only for 30 degrees. If I make some adjustment to this line, let's say, for example, I'm just extending this line. Okay. Before getting into that, so look into this array and look into this array and tell me if the base increases, height also is proportional. If this increases, it has one particular height, and if this increases, it has another particular height. If this increases, the height also increases, correct? So as the base and height are proportional. Makes sense to you? Base
yes,
and
it does.
Yes, base and height are proportional. And from this also we can conclude that base to height is constant. This is constant one. Height to base is also a constant. Height to base
All right.
is also
Yes.
constant. Yes. Now this ratio in a triangle, this is a very interesting observation. This is applicable only for particular angle 30 degree. And this ratio, let's say for example, in this particular case, we get a constant to be 0 point. So it is actually, give me a second. Yeah. So it's approximately, let's say, 0.5657, let's say. And for 30-degree, no matter small triangle or big triangle, you take the height and you divide it to the base, you will end up with some constant like this. Some constant. Okay, if this is in this particular case, if it is 0.57, it will be 0.57 even for the larger triangle A3B3 to the base. Now so if I draw one more ray with a different angle,
Okay.
getting my point? Now do you
Yes.
think, now do you think if I take new A1 B1 to the base OB1, obviously this will be constant for all other triangles like A2 B2 divided by OB2, A3, sorry, A3 B3 divided by OB3. But the ratio will differ in the sense like in this particular case, the ratio will be 1.
1, all right.
1. Okay, if the angle is 45 degree. Now the observation is that, so tangent ratio for 45 degree is constant even for a small triangle or for a large triangle.
Yeah.
Yeah. So how we can represent that this mathematically is that tan 45 tan 45 is 1. So how we obtain this tan 45 is that tan 45 is nothing but the ratio between opposite side of the triangle to the adjacent side of the triangle. So in this particular case, if this is the angle, if this is the angle, which is a side that is opposite to this angle, it's A1, B1, correct?
Yes. Yeah.
Yes. So the side that is adjacent to this angle is OB1. Okay, we
Okay.
call this as an adjacent side to the angle. So wherever you place the angle, your adjacent and opposite will differ.
Yes.
Now, so in a right angle triangle, so very important observation, for a particular angle, it could be 30 degree or 45 degree, the ratio height to the base is constant. This is the general statement. Now, for a triangle with 30 degrees, the ratio of height to base is 1 by square root of 3. This is what comes from our observation. So the other observation is that for a triangle with 45 degree, the ratio of height to base, it came to be 1 by 1, and so we are referring it as 1. Simply 1. So this is a very, very interesting observation. So it doesn't matter if you study small triangle or a large triangle. Assumed these two are similar triangles. It's not assumed, provided, given if these two triangles are similar triangles, then the ratio of height to base will be constant. So and therefore we mention this using a trig ratio called trigonometric identity. We also call this as trigonometric identity. And for tan 30 degree or for tan 45 degree, there is one ratio. We'll discover what this is, what this is all about. This is a basic idea of what a tangent for a triangle is all about. So if I draw a triangle like this, if I mark this as 45 degree, the height is this, base is this. Therefore, tan 45 height to the base. Here I'm going to give you some activity for you to work out. The activity is that draw triangle with 45 degrees. You can make it a ray in a single line itself. And for base 2 centimeter, figure out the height. You measure the height. Okay. And now take the height to base and see what ratio it comes up with. Is this activity clear?
Yes.
Okay. So and draw one more triangle. So let's say for example, if you're drawing a triangle like this, 2 centimeter, this is 45 degree, you measure this and now later you divide height to the base. Now draw one more triangle with 4 centimeter, still 45 degree this side, and measure this height and take the ratio height to the base and see if the ratio is true. It's coming out to be the same. So it should come out to be the same. So it's like you found this on your own. It's something like you discovered that height to base for two right angle triangle is always true. And we simply refer this using a tangent of one particular. So if this angle changes, what changes is your the constant value between the height to base only changes.
Okay.
This is just the kick-starting idea behind the trigonometric ratios. We'll also study that other interesting factors, like if we take the ratio between height to hypotenuse, we call this side as hypotenuse. If we take the ratio between height to hypotenuse, it is also true. And if we take the ratio between base to hypotenuse, it is also true. We'll discuss this on the next class. And this idea, we can extend this to sine ratio and cos ratio. And all you have to understand is only the sine, tan, and cos. These are the primary thing. And we'll also see how these ratios are connected in a right angle triangle. So the right angle triangle is very beautiful as compared to other triangle. And yeah, since we get to observe some interesting phenomena, and the whole of coordinate geometry is also based on this, and the whole of projections is based on this, the animation that you see. So to give you a very good example, even though the ad that is displayed in your cricket ground may not be exactly proportional. No, if you look at one particular angle, it appears like to be a rectangular thing. I can just explain you this later. I mean, the trying to explain you or give applications for trigonometry. It's projections. It's when you do an animation, when you give a shading, when you give realistic visuals. No, all this is possible because of projections and trigonometry that is actually directly or indirectly applied within the software.